In the last class, already we have discussed something on the set theory. So, what are the meaning of sets? What are the different types of operations on sets, like that? And in the case of sets, already we had the operations based on union, intersection, difference, and also the symmetric difference. Then some properties on the operations, that means either it may be commutative, it may be associative, distributive, like that. Now today there would be some algebraic properties of sets, and based on that we should prove the algebraic identity. At first, what are the meaning of algebra of sets? Algebra of sets means there may be some identities. Identities means the algebraic identity or the set relational identity. The first one is called the absorptive property. The absorptive property. Now, what is the meaning of absorptive property? Now, that is coming from the word absorption. That means some sets are there. After the operation, only one set is there on the right hand side or the equality, but another set is not there. Suppose we have A intersection A union B. Here it can be written as A. Now look at the set B. That one was on the left hand side. That one was on the left hand side, but after the operation, the right hand side is only A. That means the B set has been absorbed. That's why it is called as the absorptive property. Same as another one, as like here, that is intersection, it is union. You may write it A union A intersection B. That is also becoming only A. That means once again the B set has been absorbed. Suppose we have A is equal to 1, 2, 3. Then B is equal to 2, 3, 4. Okay, let's check what is happening here. Now, A intersection A union B. So at first we are proceeding with the A union B. So that one is A means 1, 2, 3 intersection, then 1, 2, 3, and the operation of union 1, 2, 3, then 4. After intersection, we are getting only 1, 2, 3. So that is also our A. So that means whatever be the B has been absorbed. That's why it is called as the absorptive property. That is the first one, algebra of sets. Second one is called the distributive property. Already we know that type of name. Distributive means the distribution is occurring. Once again, the distribution is occurring. First one, suppose we have A intersection B union C. Now, A is distributed with B and C. A is distributed. So A intersection B. So that means A and B. So that A is here, that B is here, and that intersection is now here. Then another one distribution, that is A with C. So A intersection C. Here what is happening? That A is here, then that intersection is here, then that C is here. And what is happening with that union? That is in between both. So once again, I am writing it A intersection B union C distribution. That means A intersection B, A intersection C, and in between the union is here. That is the first one distribution. Another one, same as A union B intersection C. A union B, then A union C, then that intersection is here. So those are called the distributive property or distributive laws of sets. First one, absorptive. Second one, distributive. Third one, already we know that name, that is called the DeMorgans Law. That is also you have learned in digital, that means in the binary number system. If we have A union B, then its complement, then we can write it as A complement, B complement. Both the sets are A complement, B complement, but here whatever is union, that must be in the intersection part. So that means A union B, its whole complement is now A complement intersection B complement. Same as if we have A intersection B complement, then that is A complement B complement. But here that one is intersection, that one is becoming union. Okay. In the digital, whatever you have learned now, that one is suppose A or B, that is after the complement, that one is becoming A complement, B complement, and same as if that one was A and B complement, so that one is A complement, B complement, or. So that one is our digital. So that one is also called as the DeMorgans laws. From these DeMorgans laws, we have another one that is called the generalized DeMorgans. Generalized DeMorgans laws. So that one, if we have A, that is the subtraction operation or the difference operation on sets, B union C, that one is becoming A minus B and A minus C. Already we have said and, so that is and. So when that one is union, that one is becoming intersection. Same as if we have A minus B intersection C, A minus B, A minus C. So that one is intersection, that one is becoming union. That is, those are called the generalized DeMorgans laws. Now, those are also the identities. Why the identities? Those are also called the algebraic identity or also the set notations identities. Why? Because the left hand side is based on the right hand side. That's why the identity holds. We can prove that type of identities or the set relations using two methods. The first one method already we have, that one is called the Venn diagram. Already we have checked the Venn diagram in the previous class, Venn diagram, but that would be checked here once again. Venn diagram, and another one method is called the variable method. Practically both the methods are very easy. Venn diagram, we have to draw the diagrams. In the case of variable method, we have to use the variable x, y, or something, any other thing. So we are proceeding at the first with the variable method. And before the variable method we would check also that type of identities. So let's start with the variable method. variable method means we have to choose any variable. Some important things. Suppose there is given x belongs to, that variable is suppose x, A union B. That implies x belongs to A union B. That means or that implies x belongs to A or x belongs to B. Already in the case of probability, we have checked that union means or. Moreover, or both. Just a single example, A is equal to 1, 2, 3. B is equal to 1, 4, 5. Now, after operation of union, we are getting A union B as 1, 2, 3, 4, 5. Okay. Suppose I am writing X belongs to A union B. Now, what is the meaning of that X? That X belongs to A union B means that sign is called the belongs to. A union B means whatever the elements are present in A union B. So those are 1, 2, 3, 4 or 5. Now X means 1, 2, 3, 4 or 5. So 1, 2, 3, 4, 5. That implies X. Suppose X is equal to at the moment 2. I am thinking 2. So 2 belongs to A. So 2 belongs to A or 2 belongs to B. That is not true, but as that is or, that is right. Suppose X is equal to 5. So 5 belongs to A or 5 belongs to B. That is not true, but as it is or, so it is true. So the whole statement is true. In that case, so X belongs to A or B. So X may be belonging to A or X may be belonging to B. Another one, or both. Or both means suppose 1. So 1 belongs to A or 1 belongs to B. Now in that case, both are true. So the statement is true as it is or. So that means that one is the most important thing when we are writing A union B, X belongs to A union B, that one means or. Union means or. That is the first one. Second one, that is the case of intersection. X belongs to A intersection B. That implies X belongs to A and X belongs to B. I am not discussing because and means it must be. So intersection means it's a common. So when the elements are common for A and B, that is treated here. So already X must belongs to A and X must belongs to B. So intersection means and. Union, intersection. Another one. X belongs to A minus B. Means the difference operation. That implies X belongs to A and X not belongs to B. Why? Because already we know A minus B. That means we are at first removing the all elements of B. We are treating only the elements of A. Then after that, whatever be the common part, we are removing from A. Suppose A is equal to 1, 2, 3. B is equal to 4, 5, 6. So A minus B That means we are removing the B at first, only writing the 1, 2, 3. Then take the common part or the common elements from A and B, that is 1 and 2. So, no, sorry, 1, 2, 3, suppose 4 here. So 1, 2, 3, 4 I have written, but the 4 is the common for both. So we are removing the 4. So A minus B means 1, 2, 3. So that is the thing, that B has been removed very easily. That is the first one thing. So here, if we write that one, that means X is belonging to A minus B. That means X is belonging to A and X is not belonging to B. Same as if we write X belonging to B minus A, that means X is belonging to B and X is not belonging to A. So that is the third one. First one, union. Union means or. Intersection. Intersection means and third one, the subtraction or the difference. That means and, but whichever is on the right hand side of the difference operator, that would be removed or not belonging to. So always that means belongs to, that means not belongs to. Those are the two. Now next important thing. Once again I am writing X belongs to A union B. So I am writing it X belongs to A or X belongs to B. Look at the thing, when that is union, that is or, and when that is belonging to. Okay, now the next part is important. I am writing X belongs to A union B not belongs to. X not belongs to A union B. Remember here, that means X not belongs to A. When that is belongs to, that means or. When that is not belongs to, union means and. Just opposite. X not belongs to B. So once again I am saying X belongs to A union B. That means X belongs to A or X belongs to B. Not belongs to A union B. That means X not belongs to A and X not belongs to B. Same as, suppose we have X belongs to A intersection B. So that means X belongs to A and X belongs to B. If we have X not belongs to A intersection B, that is just opposite. X not belongs to A in the case of and, that is intersection belongs to, not belongs to or, not belongs to B. Always remember that one. Final one we have to remember, that was if we have X belongs to A, that implies also X not belongs to A complement. That is very much true. Suppose we have a set A and X is belonging to A. So that one replies X belongs to A. So never ever X cannot belong to the A complement or A dash. So X not belongs to A complement. That is the true thing. So from the very first one, I am just writing each and every one once again. When it has X belongs to A union B, that implies X belongs to A or X belongs to B. X not belongs to A union B, that means X not belongs to A and X not belongs to B. X belongs to A intersection B, that means X belongs to A and X belongs to B, but that is not belonging to A intersection B, that means X belongs to A or X not belongs to B. X belongs to A, that implies X not belongs to A complement. X belongs to A minus B, that implies X belongs to A and X not belonging to B. Same as X belonging to B minus A, that means X belongs to B and X not belongs to A. Those are the required for our variable method proof. Yet now, is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
So let's check with the identities, whatever we have found. Suppose the very first one, that is the distributive. Suppose the DeMorgans law. First one, the DeMorgans law. Okay. DeMorgans laws. Already we have, that is A union B, its complement. That one is equal to, we have to prove A complement intersection B complement. Okay. So let an element, any variable that is belonging to A union B complement. Now we know when X belongs to A complement, that means X does not belong to A. So here we are also writing it, X does not belong to A union B. So X belongs to A union B complement, so X does not belongs to A union B. Now once again, that is means does not belongs to or not belongs to. So union, that must be AND. Once again you may check, X not belongs to A union B, so that must be AND with the not belongs to. So we are writing X not belongs to A and X not belongs to B. Okay. Next, X not belongs to A. That means X belongs to A complement and X belongs to B complement. The same thing. Now X belongs to A dash and X belongs to B dash. In between the AND is there. Now when that is belongs to and intersection, that we can say belongs to AND. So here X belongs to A complement intersection B complement. So we are getting X, the same element which belongs to A union B complement, that belongs to A complement intersection B complement. So we may write A union B complement is equal to A complement intersection B complement. That is the first one. Suppose another one, DeMorgans. That one was A intersection B complement. So here let X belongs to A intersection B complement. So we may write it as X does not belongs to A union B. If X belongs to A intersection, that one is wrong, sorry, that must be intersection. Okay. Now in the case of intersection and not belongs to, that must be OR. Not belongs to intersection, so not belongs to OR. So X not belongs to A or X not belongs to B. Same as X belongs to A complement or X belongs to B complement. That implies OR and belongs to, so X belongs to A complement union B complement. So the same element belongs to A union B whole complement and A complement union B complement. So we may write it as A intersection B complement is equal to A complement union B complement. Is that clear now, Samoy?
Yes, sir.
Yes, sir.
Okay.
Yes,
Next
sir.
one, suppose another one, the generalized DeMorgans. Okay. Check the generalized DeMorgans. So that one, suppose the first one was generalized A minus B union C. Which should be the result? Now that should be A minus B, A minus C. There is union, so that must be intersection. So that must be the equality. So same as, let we have a variable X that is belonging to A minus B union C. Now once again, if we have X belongs to A minus B, that implies X belongs to A and X not belongs to B. Same is here. X belongs to A and X not belongs to B union C. So here X belongs to A and that is not belongs to B union C. So that means we are writing X not belongs to B as union not belongs to, so that must be AND. So X not belongs to C. Now suppose some distribution like that one with that one and that one with that one in between, that is AND. So we are writing it as like the very first one, suppose with that and X belongs to A and X not belongs to B. Okay, then that and must be here. Another one with the red, we have already defined X belongs to A and X not belongs to C. Now write down the thing once again. X belongs to A and X not belongs to B. So that means X belongs to A minus B. And X belongs to A and X not belongs to C. So that means X belongs to A minus C. Now both are belongs to, and in between the and is there. So belongs to and that means intersection. So X belongs to A minus B intersection A minus C. So that one, the same element X, which is belonging to A minus B intersection A minus C, which is also same as A minus B union C. So we can say that A minus B union C is equal to A minus B intersection A minus C. Suppose another one we want to prove, that is the second generalized A minus B intersection C. So let X belongs to A minus B intersection C. So we can write X belongs to A and X not belongs to B intersection C. That implies X belongs to A and X not belongs to B as not belongs to AND, so it must be OR. X not belongs to C. Now distribution, first one, that in between AND, so X belongs to A and X not belongs to B. Second one, that one, so X belongs to A and X not belongs to C. and that or must be here. So we are writing it now finally that x belongs to A and not B. So minus B, or x belongs to A minus C. So that one, x belongs to A minus B, or as belongs to and or, so union A minus C. So finally we can say that one, the same element. So A minus B intersection C is equal to A minus B. Now that is intersection, so that is becoming union A minus C. That is the second generalized. So in that way also we can prove in the variable method any type of identity. Just we have to remember these formulas or these things very carefully. Then we can prove anything. So up to that, whatever be the equalities are, how to prove the equalities using the variable method, and that is also how we can use the equality to prove using the Venn diagram. That would be discussed after some time. This another part that is also known in the set theory, that is called the ordered pair. Very important. That is called the ordered pair, and that one is also connected with another operation of the set theory, and that one is called the Cartesian product. That means some multiplication sign, because after that whatever we are doing the union, that is looking like the addition type, whatever we are doing the subtraction, that or the difference of the two sets like subtraction. Now symmetric difference is there. Now the Cartesian product means near about the multiplication of the two sets, but we cannot directly multiply. But what is the ordered pair? That order, that term is very important. So that means A cross B is equal to, suppose we have A comma B. So that means A belongs to A and B belongs to B. Just look at the thing. A is on the left hand of the Cartesian product operator. That means the operand A is on the left hand of the Cartesian product, that operation. So that must be in the first position or in the left position, whatever you say. And the right hand of the Cartesian product operation is B. So that B is in the right operation or the right position. Okay, let's check with some example. That means if you say here something like A is belonging to B and A is belonging to A, B is belonging to A, that is completely wrong, because the order is must thing here. Let's check some example with it will be better. Suppose we have A is equal to 1, 2. Then B is equal to, suppose, x comma y. Then we are finding the A cross B. Okay. Now look at the thing, that what is the ordered pair? A is the left hand. So always in the ordered pair, whatever the elements we are getting, always the 1 and 2 that is belonging to A must be on the left hand. And how we can do it? I am just writing at first the elements, because we are getting 4 elements. So that's why. Then 1, 1. So how? 1, then 1 comma x, then 1 comma y. Same as 2, 2. That means 2 comma x, 2 comma y. Always A is in the A, B is in the B. 1 and 2 always in the first position. But that is also true. If we write that 1 comma x, 2 comma y, 1 comma y, 2 comma x, that order is not important, because already we know in any set, whatever be the order of the elements are not important. But in that case, 1x must be important. Suppose I am writing here in that way. That means x comma 1, 2 comma y, y comma 1, 2 comma x. That is completely wrong in that case. Why? Because that is wrong. And another one that is wrong. That's why. But those are true. No problem. Same as suppose we have B cross A. So B must be at first. B elements must be at first. So here we can write x, x, y, y. Then the A's element. So 1, 2, 1, 2. Now that is a B cross A. So always we have to remember whatever is in the left hand operand of the Cartesian product operation, that must be in the ordered pair, is always on the left hand or in the first position. That's why that type of A and B, A comma B, is called the ordered pair. If anyone asks, sir, if we proceed with the A cross B cross C, there is also ordered pair possible, but at that moment that is not very important. We are just considering two sets at that moment, not about three sets. Okay, that is also possible if we have A cross B cross C. That means A cross B would be first, or A cross B cross C would be first. So that should be another ordered pair like that. Okay, so but that is not in the consideration at that moment. So that is how we can check the ordered pair. Now suppose another one. Suppose we are proceeding with some examples, that would be better. Suppose we have A is equal to 1, 3, 5, and B is equal to 1, 3, 8. Then the four questions are there. Suppose first one we have to find out A cross B. The second one B cross A. The third one, suppose A cross B minus B cross A. And the fourth one, that is A symmetric difference B. So the very first one, suppose we are proceeding with 1 A cross A B. So just think about that one. Write down the 1 with 1, 1 with 3, 1 with 8. So I am writing the very first one, 1, 1, 1, 3, 1, 8. Then the second one, that is 3, 1, 3, 3, 3, 8. Then 5, 1, 5, 3, 5, 8. That is our A cross B. Same as, suppose if we proceed with the B cross A, so B should be the first one, that means 1, 3, 8. So I am writing 1, 1, 1, 3, 1, 5. Then 3, 1, 3, 3, 3, 5. Another one, 8, 1, 8, 3, 8, 5. So that is our B cross A. Next one, what should be the A cross B minus B cross A? When that is the difference operation or the subtraction operation, that means B cross A must be removed. only we can write A cross B at that moment. So we are writing just that one. So A cross B minus B cross A. I am not writing that one. I am writing just only A cross B at first. So 1 1 1 3 1 8 3 1 3 3 3 8 5 1 5 3 5 8. But that is not the answer, because after writing the A part, we have to remove the elements which are also in B. That means the intersected things. So check the which are the intersected. 1 1, yes, 1 1 present. 1 3, yes, 1 3 present. 1 8, no, 1 8 present. 3 1, yes, 3 1 present. 3 3, yes, 3 3 present. Any other elements? No. So that means we can remove 1 1 1 3 3 1 3 3. So what should be the answer here? That is 1 comma 8 3 comma 8 5 comma 1 5 comma 3 5 comma 8. So that is our subtracted part. And finally, A symmetric difference B. That one was also discussed in the last class, but once again, suppose A symmetric difference B. And which one is the formula for asymmetric difference B? Now we can write it as A minus B union of B minus A. So when that one is A minus B, what one was the A? One was A135, B was 138. So write down the A at first. Just remove the B. So 135 union of B minus A, write down the B at first, 138. Now between that, what are the common? 1 and 3. So remove 1 3, remove 1 3 also from B and A. So that is becoming 5 union 8. So the result is 5 comma 8. That is the symmetric difference. Is that clear now?
Yes, sir.
Yes, sir.
Okay, next one, we should proceed with another one thing, that is the what problems. Now the what problems, maybe we can prove using Venn diagram, using written, or any other type of way. So we should proceed with the both. Suppose the question is like that: in an exam, out of 90 students, total student strength is 90, 65 passed in physics, 50 passed in math, 35 passed in both physics and math. Now the questions are: first one, how many students passed in exactly one of the two subjects? That is the first one question. Second one, how many students failed in both the subjects? Now remember the first one thing, 65 passed in physics, that does not mean each and every one has been passed. It may possible, suppose I am one who has passed in physics, but there may be the possibility that I have also passed in math. So that 65 means passed in physics. That means the students who have passed in only physics also and also passed the math. So 65 means that does not mean only physics. Here the question is same for the math. So how many students passed in exactly one of the two subjects? One of the two subjects means we have to find out who have passed in only physics plus only math. That means who have passed only physics means in physics he has passed or she has passed but not in math. Only math means he have passed in math but not in physics. So here the universal set. Universal set according to our question, universal means the total student strength or the all students, that is given as 90. So P means passed in physics. That does not means only physics but passed in physics, 65. M means passed in math. So that means 50. Only math plus both. And finally 35 both physics and math. And means intersection. So that is our P intersection M. So passed in both P and M, that is 35. We have to find out the only physics. Now remember one second thing, how we can find the only physics. Only physics means we can say passed in physics minus passed in physics plus math. Plus means here that is and. So that means we have to find out P minus passed in physics minus P intersection M. Practically that is based on N. So that is 65 minus that is 35. So that is 30 is the only physics. Same as suppose only math. So only math means passed in math minus passed in physics plus math. So that means and, that means intersection. So M minus P intersection M. So that M means here that is 50 minus 35. So that is 15. So only math is equal to 15. So what is the first question? How many students passed in exactly one of the two subjects? So the first one answer is only physics plus only math. That one is equal to 30 plus 15 is equal to 45. That is the first one question answers. Then second question, how many students failed in both the subjects? That means no pass for physics or math. So the second question, failed in both. How we can say total students minus passed in physics only plus passed in math only plus passed in both physics and math. Already we know all the result. That means that one is equal to 90. Physics only, that is 30. Passed in math, that is 15. And passed in both, that is 35. So that means 90 minus 30 plus 15 plus 35. That one is equal to 90 minus 80 or 10. So 10 students have failed in both subjects. How we can prove it? Using Venn diagram, using only a single rectangle. So that is our first one thing, that is our universal set or our U, that is 90. Then suppose we are proceeding with the first one, that is for physics. So physics is equal to 65 who have passed. Another one, suppose we have, that is who has passed in math. So that is our math, that is 50. Now, who has passed both the subjects? Who has passed both the subjects? Now, that one is, that portion is our both the subjects. So that means that is our P intersection M, that is given as 35. So passed both the subjects. So only physics. So only physics. So if we consider that portion is our only physics. So how we can say it? That one? That one is 65 minus 35. That is only physics. And that one means 30. Same as if we proceed with the only math, that means that one is our only math. Okay, so we can proceed with that one. So that is our only math. So only math means 50 minus 35, that portion. So that one is 15. So if we want to find out the first one, who has passed only physics plus only math. Whatever I have drawn here using color, that is not important for your proof for the Venn diagram. I am just to demonstrate it, I have drawn it or I am coloring it. So only math, that is equal to 30 plus 15 or 45 here. And who has failed? The fail portion is only the white portion. That means among 90 students, only the white portion is failed in both subjects. So that is 90 minus only physics 30 plus both passed 35 plus only math 15. So that one is 90 minus 80 or 10. So we can also say here that 10 is also present here. From Venn diagram, we can also say that 30 plus 35 plus 15, 90 minus 10, 80, that is 10.